So in this video, we're going to continue exercise 1523, which was asking us to draw the resonance structure indicated by the curved arrows and to be careful about formal charges in each of these different structures. So let's do E. Now the first step in all of these is just to redraw the molecule exactly as it is. So all of the bonds, and here I'm just going to expand this. There's really a bond between the oxygen and the hydrogen there, so I'm going to draw that there. Hopefully it'll make things a little clearer. And we've got double bonds here. Okay, before we think about the curved arrows, let's think about hydrogens on the relevant atoms. Now notice, the atoms where electrons are moving, and so where formal charges might change, are these atoms right here. Well, I guess not necessarily the hydrogen, but each of the other ones. And so, those are the atoms where we want all of the hydrogens drawn explicitly. So let's start with this carbon here. This carbon here. So in this one, that carbon does not have a formal charge, and so it needs 4 bonds. It has 1, 2, 3, 4 bonds drawn to it, so it does not have any hydrogens. Okay, next hydrogen over, next carbon over, this one right here. That carbon does not have a formal charge, so it needs 4 bonds. It has 1, 2, 3 drawn. That means it needs 1 more, so there's going to be 1 invisible hydrogen there. Next, carbon at the bottom right. So this carbon does not have a formal charge, so it needs a total of 4 bonds. It already has 1, 2, 3 drawn. That means it just needs 1 more, and that'll be to an invisible hydrogen. Carbon at the very bottom, so that carbon does not have a formal charge, so it needs 4 bonds. 1, 2, 3 are already drawn, so it just needs 1 more, and that will be to an invisible hydrogen. At the bottom right, this carbon here, that carbon does not have a formal charge, and so it is going to need 4 bonds. 1, 2, 3 are already drawn, and so you just need 1 more, 4. That will be to an invisible hydrogen. Oh, and actually we didn't even need to do that one, right? Just to save time, I'm going to erase that. We really only need to pay attention to the places where the curved arrows are moving. It was so much fun I was unable to pull myself away from drawing those hydrogens in. I'm sure you'll forgive me. So, now that we have the hydrogens drawn, let's look at the curved arrows and we'll move electrons according to what they're doing. Now, any electrons that are at the tail of a curved arrow are electrons that are moving away from that place. So you want to erase those. Any electrons that are at the head of a curved arrow, or wherever the head of the arrow is pointing, is a place where electrons are arriving, and so you want to draw electrons at that place. If the arrow is pointing at a bond, then you draw a bond. Any place where there is the tail of a curved arrow is a place where electrons are moving away from, and so you erase the electrons there. Any place where the head of a curved arrow is pointing is a place where electrons are arriving. If it's pointing at a bond, then you draw a bond. Any place where you have the tail of a curved arrow is a place where electrons are moving away from, and so you erase those electrons. Any place where the head of a curved arrow is pointing is a place where electrons are arriving, and so you want to draw those electrons. If the head of a curved arrow is pointing at an atom, then you draw the electrons as a lone pair. So that takes into account all of those curved arrows. So now we just have to go through the relevant atoms and look at the formal charge. Let's start with the oxygen. Oxygen is in group 6A minus. We have 2 dots here and 3 lines. That's 6 minus 5. So this oxygen is going to have a positive 1 charge. This carbon is in group 4A. Notice there are 4 lines around it. 1, 2, 3, and 4. 0 dots, so that has a 0 formal charge. This next carbon, 4 minus 0 dots plus 4 lines. Notice 1, 2, 3, 4. And so that has a 0 formal charge. You might notice that is the same for this one. There are 0 dots there. There are 4 lines, 1, 2, 3, and 4. And so that also has a 0 formal charge, that carbon. How about the bottom one? This bottom carbon is 4 minus, we have 2 dots now, and if you notice there's 1, 2, 3 lines, so that's 4 minus 5. That carbon is going to have a negative 1 charge. So I'm going to draw a negative 1 there. And so that would be the structure that the molecule on the left is trying to communicate to you with all those curved arrows. All right, let's try F. First step, redraw the molecule exactly as it is, just without the curved arrows. Okay, and we've got a positive charge on this nitrogen. So now, let's draw in the atoms whose formal charge could possibly change. Those are the ones that are involved in these curved arrows. So that's these here, there. These are the ones that could possibly change. So if any carbons in there, we want to draw the hydrogens on them so that we can figure out the formal charge more easily later on. And so this is our first carbon right here. Our first carbon is right there. And that carbon does not have a formal charge, so it needs 4 bonds around it. We've got 1, 2, 3, 4. And so it doesn't have any invisible hydrogens. This carbon here has no formal charge, so it needs 4 bonds. 1, 2, 3 are drawn around it. That means it needs an invisible bond to a hydrogen, or a bond to an invisible hydrogen. Oops. So we've got that hydrogen there. Next, the carbon at the bottom here. Oops. So this carbon here. That carbon has no formal charge, and so it needs 4 bonds. 1, 2, 3 bonds are drawn, and so the 4th bond is going to be to an invisible hydrogen. And last but not least, for the relevant atoms, the atoms whose formal charge could change because they're near the curved arrows, is this one at the bottom. Now, that carbon does not have a formal charge, and so it needs 4 bonds. It has 1, 2, 3 bonds drawn, so it just needs 1 extra one to an invisible hydrogen. All right, now that we've drawn in the relevant hydrogens, let's move the electrons in the way that the curved arrows are telling us to. Any electrons that are at the tail of a curved arrow are moving away from there, and so you erase those. Anywhere where the head of a curved arrow is pointing is a place where electrons are arriving, and so you draw those electrons in. If the head of the curved arrow is pointing at an atom, then you draw in lone pairs. Okay, that takes into account one curved arrow here. Anywhere where there is the tail of a curved arrow is a place that electrons are moving away from, so you erase those. And any place where the head of a curved arrow is pointing is a place where electrons are arriving, and so you draw those in. If the head of a curved arrow points at a bond, then you draw in a bond. All right, let's go to the third curved arrow. Any place where you have the tail of a curved arrow is a place where electrons are moving away from, so you erase those electrons. Anywhere where the head of a curved arrow is pointing is the place where electrons are arriving, and so you draw in electrons. If the head of a curved arrow is pointing at a bond, then you draw a bond. Okay, now that we've moved all the electrons, we just have to go back and check the formal charges on each of these things, see if they've changed. First, the oxygen. Oxygen is in group 6A, so 6 minus 6 dots there, 1 line. That's 6 minus 7, or negative 1. So this oxygen will have a negative 1 charge. How about the nitrogen? Nitrogen is in group 5A, so 5 minus, there are no dots there, and there's 1, 2, 3, and 4 lines. So 4 lines, so that still has its positive charge. This carbon here, 4 minus 0 dots, 4 lines, so 0. This carbon here, 4 minus 0 dots and 4 lines, so 0. This carbon here, 4 minus 0 dots, 4 lines, right? 1, 2, 3, 4. And so that also has a 0 charge. So all those carbons have a 0 charge. Okay. Last but not least, let's look at this bottom one. It's carbon, so 4, minus 0 dots, and how many lines do we have around this carbon? 1, 2, and 3. 4 minus 3 is positive 1, so that carbon there will have a positive 1 charge. So, the molecule that all the curved arrows are trying to communicate to you on the left is this molecule on the right. All right, G. First step, redraw the molecule exactly as it is, just without the curved arrows. So we've got this, negative charge, double bond to oxygen, lone pair, positive charge on the nitrogen. Okay. So, the places where the formal charge could change is in these atoms here. Those are the atoms that have curved arrows connected to them in some way. So those are the ones that we want to take into account the hydrogens of. We don't have any carbons there, so there are no hydrogens to draw in. So we can jump straight to looking at how the curved arrows move electrons. Oops. Any curved arrow that is at the tail of a curved, any electrons that are at the tail of a curved arrow are electrons that are moving away. So you erase those. And anywhere where the head of a curved arrow is pointing is a place where electrons are going, so you draw those in. If the head of a curved arrow is pointing at a bond, you draw in a bond. How about the other curved arrow? Any place where a tail is meeting electrons, those electrons are traveling away, so you erase those. Any place where a curved arrow is pointing is a place where electrons are arriving. And if a curved arrow points at an atom, then they arrive as a lone pair. Okay, now that we have moved the electrons, let's think about the formal charge. Start with the oxygen on the left. Oxygen's in group 6A minus, we have 6 dots here and 1 line around that oxygen. So that's going to have a negative 1 charge, so negative there. The nitrogen is in group 5A. We have 0 dots around the nitrogen. If you count them, 1, 2, 3, and 4, there are 4 lines around the nitrogen. So 5 minus 4 is positive 1. So it keeps that positive 1 charge. And then this oxygen on the right, oxygen's in group 6A minus, we have 4 dots plus 1, 2 lines. So that's 6 minus 6, that's 0. So this no longer has that negative charge, has a 0 charge. And so this structure here is the structure that the curved arrows in the molecule on the left are trying to communicate to you. All right, last but not least, H. First step, redraw the molecule exactly as it is, just without the curved arrows. Now, we only want to look at, the next step is drawing hydrogens, but we only need to do that on relevant atoms. So those are the relevant atoms, the ones that are near the curved arrows that are involved in the movement of these electrons. So we want to draw the hydrogens in on each of those carbons. This carbon here, none of these carbons have a formal charge, so all the carbons are going to want 4 bonds. This carbon that I have the arrow pointing to now, that has 1, 2, 3, 4 bonds drawn already, so it must not have any bonds drawn to a hydrogen. It has not bonded to any hydrogens. This carbon here has no formal charge, so it needs 4 bonds. 1, 2, 3 bonds are drawn, already, so it just needs one more. That's going to be to an invisible hydrogen. And this carbon here has no formal charge, so it needs 4 bonds. 1, 2 are already drawn, and so it just needs 2 more. Those are going to be 2 invisible hydrogens. So now that those hydrogens are drawn in, we can look at the curved arrows and see how the electrons move. So any place where the tail of a curved arrow is pointing from is a place where electrons are moving away from, so you erase those. And any place where the head of a curved arrow is pointing is a place where electrons are arriving, and so you draw those in. If the head of a curved arrow is pointing to an atom, then you draw those in as a lone pair. All right, let's look at the other curved arrow. Anywhere where the tail of the curved arrow is pointing from, those are electrons that are moving, so you erase those. Anywhere where the head of an electron is pointing to is a place where electrons are arriving, so you draw those in. And if the head of a curved arrow is pointing to a bond, then you draw a bond. Okay, now let's go over each of these atoms and check the formal charges on them. First, the oxygen. It's in group 6A, minus, it has 6 dots and 1 line around it, so this oxygen will have a negative charge. This carbon's in group 4A, has 0 dots, 4 lines around it, so that carbon has a 0 charge. This carbon here, it's in group 4A, minus 0 dots, and there's 1, 2, 3, 4 lines around it. So it also has 4 minus 4, or a 0 charge. Finally, the carbon at the right, that carbon is in group 4A, 4 minus, there are 0 dots around it. There are 1, 2, 3 lines. So that's 4 minus 3. That is a positive 1 formal charge. And so when you look at the molecule on the left here, and you look at what those curved arrows are trying to tell you, they're trying to tell you that the electrons move in such a way as to create this molecule on the right. So in all of this whole long problem, they've used curved arrows to show how electrons can move through a molecule.